Alright, so we want to make sure we get this idea down. Remember, exponent means we're going to repeat that multiplication. So 3 times x, so that'd be like 3 times 5, whereas 5 to the third, that's going to mean something different, right? It's 5 times 5 times 5. Right, so this would be 15, this would be 125, and I think we'd agree that they're very, very different. Alright, again, so whenever we have those same bases, right, the 2's are my bases, I'm going to add those exponents to get 5. So if I take those 2's and I turn into a variable, right, I get x to the third, x to the fifth, we're going to add those and get x to the eighth, as long as they have the same base and we're multiplying. So that's what we fill in here. Why do we call it the product rule? Okay, because we're multiplying with those like bases, that means we're going to add the exponents. Okay, so if I leave a generic algebraic one, so algebraic rule means we're going to put everything in as variables. So what should I do with n and m? I should add them. Okay, so that gives you a general rule. Now, you know, in isolation these are going to be okay, but we're going to start to mix them up with our various rules. So I'm going to get each one down through each part here and then go from there. Distributive rule for exponents. So I want to make sure I have 4 to the fourth and 6 to the fourth, and we can leave it just that way for today. So if you have multiple items in here, they're being multiplied, so multiple factors, and a power, then that power goes to everything. Right? We call it distributive rule because it looks a lot like distributive property, but it's coming in from the exponent. So if I had 2x the whole thing to the third, and we've seen this a little bit already through some fractions and things like that, that means we have 2 to the third and x to the third. Okay, so as we go forward through this, like that shows me you understand the rule, but 2 to the third is the 8, and x to the third will be that. So that's what we're looking for as a final answer, but as long as we're in the middle right now, we're okay. But keep in mind, we do want to progress to know how to work with 2 to the third, or anything to the third or fourth power on our calculator as well. Alright, quotient rule. Quotient means we're going to divide something. And when we divide, right, so what we can do is actually take and subtract. So 7 minus 4 is 3. So that's 3 to the third. Why can I do that? Because the bases are exactly the same. Okay, and if I have multiple of the same bases, then we can go ahead and fill all that stuff in. So we don't really want to write this out and get rid of those. Okay, but we do want to subtract, and we're going to leave the result wherever we have more of them. Okay, so if we go to write them out. So we'll show you a couple examples of that in the next couple of days as well. Our general rule, if we have the same base, so that's my x's, I want to subtract those exponents. So subtracting the exponents when dividing the same base. So a lot of times we think about addition and multiplication tied together, multiplication and now division and subtraction being put together. So let's come up with one here. 5 to the fifth over 5 to the negative second. What? Can I do that? 5 to the 5 minus negative 2. So that's 5 to the seventh. Right? Now I know we can talk about that negative 2 because we've already done that rule along with 0. Alright, 0 exponent rule. So when we divide all of these, we're going to end up with 2 to the 0, 5 to the 0, x to the 0. Okay, just make sure that turns into 1. If there's anything else involved, okay, so we do say that anything to the 0 power is 1. Just be mindful of anything else. Like we have something like this, negative 3 to the first, x to the 0. So that's negative 3 times 1, so this answer is just negative 3. Alright, so we've had a chance to kind of work on this a little bit. We know that it's not automatically 1 as soon as I see something to the 0 power. We really have to be careful of what else is involved in the problem. Okay, but plain old a to the 0, that is 1. That's okay. Alright, this is the one we ran into just a little bit early. If we want 2/3 to the fourth power, we essentially want that distributed exponent to each one. Why is it? Because it's repeated multiplication. So here I have 4 of the 2's, 4 of the 3's. Okay, so 2 to the 4th, 3 to the 4th. Okay, now notice with the numbers here, I just want to make sure we have the idea So I'm okay with whatever you write down there, but eventually we want to change those. And if we don't know what power it is, this is certainly helpful that it's a to the nth and b to the nth. We don't really know what else is going on. So using that idea to distribute, when we had something like 2x to the fifth, remember this was 2 to the fifth and x to the fifth. Now if we have it in a fraction, that means we're going to distribute to the top and the bottom. So I kind of represented both of those with this example here. We'll zoom in a little more. So this is 2 to the x, a to the x, over 3 to the x, b to the x. So this x power goes to every single thing in here. Regardless if it has a power already or not, we would just multiply that. Right now its invisible power is 1. So this is where things will start to get a little bit hairy, but we're going to do enough practice the rest of this week to get it down. Alright, power rule. So this is a power to a power. And this is the one kids sometimes get mixed up here. So that means I need 5 to the third, 5 to the third, 5 to the third, and 5 to the third. Well, once I do this, it turns into the addition rule. So 3 plus 3 plus 3 plus 3, well, that's 6. Wouldn't it be nice if we realized that if I just did power to a power, 4 times 3 is 12, and went straight to my answer way over here. So if you have a power to a power, we're going to multiply. Okay, so with power to a power, we're going to multiply. So that's what I have modeled right here with that algebraic rule. This is the way you would see a rule if you went to look up just how the rule works to see what's going to happen. Okay, I think the next to last one, if I jump back and forth here, sorry about that, is probably one of the most telling ones. So you can also have that distributive property part of the rule. So here's our 3 to the 15th and y to the 6th. Okay, if we choose not to write every single thing out. Okay, but by all means, if you get confused, go ahead and write it out. So that you would have 3 to the 5th, 3 to the 5th, 3 to the 5th, y to the 2nd, y to the 2nd, y to the 2nd, and then you can go back and use your product rule, which means you're going to add those together. So it works both ways. So you have a way out if you forget, or a way to just to check it. But I don't think you want to write a to the 20th 32 times. So just multiplying here is going to make your life a little bit easier. Alright, so we're going to multiply exponents for one base term. Okay, so if you have power to a power. And this one does move in all over the place. So let's make it 2 to the 5th, x to the 3rd, y to the 4th, and let's take all this to the 3rd power. So that means we want 2 to the 15th, x to the 9th, and y to the, don't forget the bottom, 12th. And you can imagine if I use negative any place. Right, so let's go back to, let's say it was x to the negative 3rd. So here's what I have so far. So 2 to the 15th, x to the 9th is going to move down, and y to the 12th. So these are going to get intertwined and used all over the place. So we're going to keep them all straightened out. Alright, speaking of negative exponents, this one we should be pretty happy with. We kind of know what's going on with it. We know 2 to the negative 3rd, so we would make it 1 over 2 to the 3rd. This goes along with our division rule when we subtract, right? Because 2 minus 5 give me that 2 to the negative 3rd. Well, that means it should be 1 over 2 to the 3rd is our final answer. In the middle, we kind of show what's going on. 2 times 2, we got 5 of them here, so we're going to cancel these out. So I ended up with 3 2's on the bottom. So that's how it works out. So if you forget what's going to happen, then we can always write it out. Or one thing I encourage my students to think about is if I have 4 on the top and 9 on the bottom, where do I have more? It's on the bottom. How many more do I have? It's 5. So that's our subtraction rule, except we get to skip out on kind of the middle of saying my answer is a to the negative 5th and then moving it. So where do we have more? So 4 to the negative 8th when I subtract, so it's 1 over 4 to the 8th. And we can throw in some extra stuff. Notice the y doesn't have anything to reduce with, so it's just going to hang out and be part of the answer. With my x's, I end up with 4 more on the bottom, so it's y over x to the 4th. Again, we have some things written over here to try and help out with that. And it does go along with making sure that we have similar bases. So we end up with two separate problems in here, and that's not a problem. Okay, 5 to the 0. Not sure why that one made it in there, right? It's just 1 over 25 to the 4th power. That'd be the easiest way to deal with it. But that negative exponent means we're going to change the location of that fraction. And we're going to change the sign. Right, we've been kind of used to that, I think. Our positive expressions with negative exponents negative. No, remember negative exponents is just going to change the location of the fraction. It has nothing to do with the actual numerical value. Yeah, so to reiterate that, if I have 1 over 2 to the negative 3rd, well, this is positive in the top, negative in the bottom, so this term is going to move. So it's 2 to the 3rd on top, which is just 8. Okay. And notice, even though we had a negative exponent, it's still going to be a positive number, and that's not a problem. Okay, so last one we had here, so this is just x to the y power. You can put it over 1 if you want to, but we don't need to. So that kind of gets all of our rules in a nutshell. We're going to spend the next few days practicing those.